Hello everyone, this is my major project. It's a fuel efficiency prediction using machine learning algorithm. I have done this project under the supervision of Mr. Grijarajan sir. He's my mentor and guide, and I have done this through Medfin. And these are my industry details. I have done 5 months of internship here under the lead by Jagdish. And coming to my abstract, actually consumption of fuel is increasing nowadays, and the manufacturing of fuel, and it's very difficult process. It involves a lot of effort, like it involves a lot of budget and everything. So using the fuel in an efficient manner really helps in a economy, not only in terms of economy, it also decreases the pollution and all. So it's a better way to use the fuel in an efficient way. So for this, we are taking some attributes of a vehicle like a displacement, a weight, and horsepower, cylinders, etc. Through that, we will be finding out for what attributes, I mean, what type we need to use so that we can make an fuel efficient vehicles so that it will be very efficient way. And our main aim of the project is to predict the vehicle's efficiency, fuel efficiency in terms of MPG. And the scope of the project is to develop machine learning models by taking the better attributes, better data sets, etc. And this is our introduction. As I said earlier, we'll just take some attributes and just pick out whichever attributes work out properly for fuel efficiency. And we have taken some literature papers, and with that help, we have done this project. These are some reference literature reviews. We have done this project in a modules way. I mean, like module one, module two, like this. And first module is like data collection, pre-processing data, building the model, training and testing. Coming to deeper into the modules, like first module is data collection. We have collected the data. We have taken a data set from Kaggle, which contains some attributes like almost it contains some 1501 data sets, and it contains attributes like MPG, cylinders, displacement, horsepower, weight, acceleration, and model year. And coming to next step, it's a pre-processing of data. Actually, the data set contains some null values. To fill up those null values to test the model in an accurate way, we have done some box plots so that we found those medians for every attribute, so which will be helpful for filling out wherever the null values are there. We will fill them with medians. And we have done this project in two models. One is linear regression and other one is random forest. We find out that the random forest got some better outputs, I mean, better R2 score with less errors, I mean, more accuracy. So that we have finalized the random forest and just implemented that. This is the data flow diagram, like it involves the steps like data collection, pre-processing, building model, etc., testing, training. And this is a unit testing and all. This slide just later I'll show on the execution part so that it will be a better understanding. Till that, this is a just simple interface. Like we'll be giving this type of data as an input, like MPG, cylinders, displacement, horsepower, weight, and class will predict the output. And apart from that, we'll also do some data visualization where we'll be getting some graphs based on the attributes. Like for example, just here are the two graphs, which is mileage versus horsepower and mileage versus weight in cases. It is a like it shows how the horsepower and mileage are related and how weight in cases and mileage in KPL are related. And according to conclusion, like as fuel price is increasing rapidly because the manufacturing of fuel is a real task. Like it takes a lot of efforts, a lot of money, a lot of like resources, so that using the fuel in an efficient way really helps. For this, we are giving, I mean, this may not be like more advanced than for automobiles, but it may help the automobiles like to design their vehicles in a better way so that they can consume less fuel. It will be beneficial for both automotive industries and also people and also environment. These are some reference links. We have referred these videos and this reference for doing our project successfully. This is some plagiarism report. These are the references we have taken. And this is some photos in our industry, and this is my certificate of internship, this poster. And this is the end of PPT presentation. Now I will show you the execution part. I have done my project in Google Colab. Like this is the interface. Like first we need to import the modules like pandas, evones from Python. I have imported that, and we need to I have already uploaded this data set here. We need to upload the data set and copy the path like this, copy the path and paste it here, so that run the data set, so that it will by using this pd.read csv command. It just reads the data set. After that, we'll be running this data.head, like which gives data. This data.head shell will give this output as like top five, not top five, actually first five attributes. Like what are the attributes it is having for first five records? Like for this first 0 to 4, like what are the attributes it's having and their values for just reference purpose. And next we'll go for data describe method. Like this method gives out like for attributes what are the count. Like as I said earlier, we're having some 1510 records, and what is the mean for mpg, what is the standard deviation, what is the minimum value, what is the maximum value, like this. It will be it give for all attributes. And after that we'll check whether there are any null values or not. Like after checking, we have found that the horsepower contains some 20 null values. So that we need to replace that null values with median. As I said earlier, we have done that. We have done this box plotting. Like after doing this box plotting, we have found the median of horsepower. So that we'll be replacing that median here. Like as you see, median of horsepower, like wherever it is null, we'll be replacing it using this function. And after that, we'll be cross-checking again whether it is replaced successfully or not. Here we can see that the horsepower has zero null values, everything has zero null values. So we are ready to go now. And this, as I said, we have done some data visualization techniques, like created some graphs as well for better understanding and for better reach. We have done this pair plotting among each attribute. I mean, like for example, like mpg cylinder displacement, weight, horsepower. Like 1 second, it's yeah. And like mpg to mpg and mpg to cylinder, like you can check out here what are the graph unit is mpg to displacement, displacement to cylinder, or whatever the relation may be, it would be showing better in the graphs. After that, and this extracting the name of the brand. The data set contains like a lot of models. I mean, a lot of brands like Ford, everything. For each brand, there might be some different models. So we are considering a model of an every brand as a single entity, I mean single brand. So that we need to extract the brand names here. So we'll get the list of brands, like, and also we'll be replacing like some may be written as Volkswagen, VW, like Mazda, Toyota, Mercedes-Benz, Mercedes, like this. Everything belongs to same. So we need to replace them with the same name, right? So we'll be doing that here. So that we'll replace whatever be the name, we'll replace that. And after that, we'll count the values. I mean, what brand contains the highest. I mean, count of each brand. Like we'll be getting this output as Ford has 200 entities, Chevrolet has 182, like that, same Toyota has 96, like that. After that, we'll be plotting a graph, like showing this data. It shows that Ford has highest number of vehicles and last Fiat, something like that. And after again, we'll do this data set, data.head. As I said earlier, it gives the top five, I mean, not top five, first five attributes and their values. And after that, we'll convert as a this data set is an international standard. It has some international units, but we are doing it and I mean Indian standard unit, so that we need to convert some cubic inches to centimeters and lbs to kgs, everything, and mpg to miles per gallon to kilometers per liter. We are using these three functions and converting everything to Indian standards. And after conversion, again we'll use this data.head. Again we will going to check what are the values of those attributes. After that, again this data.info will give the what are the attributes having, what are the count, what is that data type, everything. We'll be getting these 12 attributes, or what is we'll be getting our idea. And after that, we'll be converting as a type integer as horsepower is in float. And next, we'll be taking as a these data set contains three origins, and we have taken three origins like USA, Europe, and Japan. Like, and also we have taken this origin and performance versus graph. Like, what is the mileage impact on origin? Origin means, I mean, what origin the car is coming, the vehicle is coming. What's the impact on mileage? Like we have taken three origins: American, European, Asian. Like we have given their numbering also, like 1, 2, 3. This will be useful when we're giving an input in a website. And it's clear like which has a good impact, which origin vehicle has good impact on mileage. We'll be getting, and again we also plotted same type of graphs for mileage and number of cylinders, like what is the impact if the number of cylinders are more, what's the mileage impact and all. And here, more the number of cylinders, more the power will be burned on the fuel, so mileage decreases. as it's natural, right? If it has a high power, high and cost, the mileage will be automatically less. Next, we have plotted the pie charts for cylinder data sets. So this pie chart shows the same things and what these all are data visualization tools because to better understanding the model. And plotting the block spot is also observe performance better here. And after that, completing these are all same graphs and all weights per weights and mileage, everything. This is a graph between weight and mileage, and this is dropping out the data. So, I mean, displacement, weight, name, brand, FPG is not required for us, like for calculating, for reading out the data. So we'll drop out that, and again we'll do this data head. We'll check out the attributes whether they are correct or not. After that, we'll go test it. We'll plot the heat map. This is very important. Like this also heat map shows the attributes and their values so that it will be beneficial. After that, we'll again check this data head, which is useful, like taking out this, dropping out this mileage, because we need to get this mileage values from the machine learning algorithm. Now from now the actual model starts here. Like we'll be importing the modules, and for that we have imported the linear regression model, and we have trained the data here, like done this linear regression model trained. After that, we have like predicted like what's the output for that. Like again we have done some L2 scores values and all, because like we need to test whether the module is correct or not. Here for linear regression we got some 82%, somewhere around it will be some 82.2% R2 score, and some mean absolute errors 1.06, 1.89. So we have like for example we have given some attributes, like you can go check this order, like for 129.7 this belongs to like these attributes like cylinders, horsepower, acceleration and all. So after this, one second. Yeah, after that, we'll be getting this output as 15.42. This is in mileage for these given attributes. We'll be working out with random forest again. As compared to linear regression, this random forest has high accuracy and high R2 score value, so that we have finalized that way our model will be running as random forest. Here you can see that it's 99% R2 score and an absolute error is 0.09, 0.34. Attributes, the mileage is around 12.9, which is almost similar. I mean, not exactly same, but it's almost similar. After that model of evolution, like we have taken a JSON script. We have given each and attributes their values in a JSON format to the system, so that we can be calling through APIs and all. So after that, this is the same as output 0, 4, 129.7 Excel model year, something like that. 3 here origin, 3 means the sense Asian. Like again, we have predicted that we'll be getting this 13.313 as a mileage for this given attribute. So now this same we have done in web app where we will be giving this user is allowed to give this attributes so that he'll be getting this mileage. And this is our project. Thank you. Thank you.